welcome to our lessons. I hope you guys have been enjoying watching these and learning from them. We are going to go ahead and jump right on in to our lesson 22 of our module 5. You guys are almost done. This module, you're working through it. Like we've been working through during this entire module, it's on fractions, and we're kind of getting into some more complicated concepts. So just continue to work through it with me. We're going to keep tackling all of this together, and just know that I am always here to help you guys as you continue to work through these concepts. So let's get started. I am going to tell you that I'm going to try to go relatively quickly, and then I want to show you a cool resource you guys can use online. So our objective today is to generate simple equivalent fractions by using visual fraction models and the number line. So we're still trying to figure out what equivalent fractions look like. Remember, they're ones that might have different numerators and denominators, but really they equal the same thing. So our fluency practice really quick right now is we are going to be counting our fractions on the number lines by thirds. We're going to count by thirds. So on your notebook, I did forget to say this in the beginning. I would like for each of you guys to have a blank piece of paper, pencil, marker, crayons, whatever you want to write with. And you should have a blank notebook or paper in front of you so that you can take notes while we go through our lesson. That way, you're proactively learning while I'm also showing you and talking you through these lessons. So go ahead and draw this number line, and then you're going to make 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 lines. So there are 13 lines. And we were going to start at the beginning, and we're going to count by thirds. So we should label the first one as 0 thirds, 1 third, 2 thirds, 3 thirds, 4 thirds, 5 thirds, 6 thirds, 7 thirds, 8 thirds, 9 thirds, 10 thirds, 11 thirds, and 12 thirds. Now, what's really cool about this is you guys can really take a good look at how the denominator, or the number on the bottom, never changes. We're still only talking about thirds. The number on the top increases by 1 as we increase by 1 space. Really, before we go on to our application problem, I am going to just take a moment and I want to highlight. I'm going to use the highlighter. I'm going to highlight where our whole numbers would be. So if we're talking about thirds, that means between 2 whole numbers, there should be 3 equal spaces because we're talking about thirds. So I'm going to highlight the fact that 0 thirds is in fact a whole number. Okay, so I can even write a 0 on the bottom. Okay, and then if we skip count by 3 equal spaces, we would have 1, 2, and 3. And so you guys know that 3 over 3 is equivalent to 1 whole. When the number on the top and the bottom are the same, that's 1 whole. Then we keep skip counting. We can go 1, 2, 3. So 6 thirds is equivalent or the same as saying 2, a whole number of 2. We go 1, 2, 3. 9/3 is the whole number of 3. And then 1, 2, 3. 12/3 is our whole number 4. So from 0 all the way to 4, we had skip counted in thirds. Okay, now we are going to get started with our application problem, and as always, I'm going to read it through. We're going to follow the directions that are labeled here for A and B, and I would like for you guys to go ahead and write some notes down, try to solve this problem on your paper, really try to think through this application problem. I'll try to pause through some of the questions I might ask just so you can try to answer them before I answer them on our video. So let's get started. It says, Mr. Ramos wants to put a wire on the wall. He puts 9 nails equally spaced along the wire. Draw a number line representing the wire. Label it from 0 at the start of the wire to 1 at the end. Mark each fraction where Mr. Ramos puts each nail. So, the first thing we are going to do before we even go ahead and answer A and B is right in my blank space right here, I am going to go ahead and draw that number line. Okay, I'm going to draw the number line and I'm going to use my pen. And I would like for you all to make sure you are also drawing a number line. Now, one of the things it says is that it says there are 9 nails equally spaced. Now, that does not mean we're talking about ninths. And I'm going to show you exactly what I mean by that. So, using your marker, pen, pencil, whatever you're using, we are going to start at the end and I'm going to put my first nail in. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to just double check. I want to count those out loud with you all. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 nails equally spaced along the wire. Now we need to label it from 0 at the start. So here's my 0, and then 1 at the end. So our whole number of 1. Now, if you look at it like that, how many equal spaces do I have between 0 and 1? I would have 1, 2, 3, 4, 5, 6, 7, 8. So we are talking about 8s. Okay? So we are talking about 8s. Now, part A says to build a number bond with unit fractions to one whole. What that means is you should draw the number 1 as a 1 whole. And this is where we make all those little spider legs. And you would do the unit fraction. Our unit fraction for 8s is 1/8. 1/8. How many 8s do we need to get into to make 1 whole? We need 8 1/8s. So you should have 8 legs. So here's 1/8, Here's another eighth. And you would keep going. Now I'm going to show you my next slide exactly what I'm talking about. And you can keep drawing all of your spider legs. I also want to challenge you to, now I don't have enough space, but I'm going to try my best to draw and label your number line. So here's 0/8, here would be 1/8, 2/8, 3/8, and so on. So you should go all the way until you get to 8/8. That will also be on my next slide. So go ahead and make sure you complete our spider legs. There should be 8 of them. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 8. And then you should also be labeling your number line. Okay, so here we are. So for those of you who are looking at this screen right here, you're going to see I labeled my number line. I did this ahead of time so you guys can see it more clearly. And so this was part of that beginning paragraph. This is what it was asking you to do. We were to label it from 0 to 1. We figured out there were 8 equal spaces, so we were talking about eighths. So we went from 0/8 all the way up to 8/8. Part A was asking you to build a number bond with unit fractions to one whole. What that means is after you figured out there were eights, you had to figure out how many eights did you need to get to one whole. You needed 1, 2, 3, 4, 5, 6, 7, 8. Now, part B is a little bit tricky. I noticed how I did not talk about it on the previous slide because I did want you guys to see my completed number line. Part B asks us to write the fraction of the nail that is equivalent to 1/2 of the wire. Now you have to think about this. What is half of the wire? Now I could eyeball it and I could say, okay, it's going to be somewhere around here. Here's somewhere in the middle. We know that a half is in the middle. Okay, between 0 and 1, there should be a in the middle. But if we want to look at that, when we think about something being half, there needs to be the same amount on either side. So if we cut 8 in half or divide it by 2, okay, we divide it by 2. I just actually did that wrong. Let me just really quickly erase it. Okay, so if we go ahead and divide it by 2, okay, we know that 8 divided by 2 is 4. So to find the exact half, we can count 4 because there should be 4 on either side. So this would be 1, 2, 3, 4. So I'm going to stop right here. And then just to double check, there is 1, 2, 3, 4 on the other side. So 4/8 looks like it's in the middle. Okay, it is in the middle, and so that is equivalent to 1/2. This would be equivalent to 1/2. So 4/8, to answer our letter B, 4/8 is equivalent to half of the wire. 4/8 is equivalent to half of the wire. Now this will make more sense as we continue to use different methods of looking at our fractions and number lines. Okay, now on your journal, I want you to make sure you have a new blank page. And I showed you guys this in our previous lesson. These are all of our fraction bars. We're going all the way from 1 down to 1/12 or twelfths, okay? I want you guys to think about what is a fraction, or name the fraction, that is equivalent to 1/3. Name a fraction that is equivalent to 1/3. So here is 1/3, okay? And we can look at 1/3. Now, remember in my previous video, I had said if you drew a line straight down, it should line up perfectly. If I had my cubes that we use in the class, I would have you take 1/3 and see what lines up with 1/3 perfectly. But we can't do that, sadly. So I want you to imagine drawing this line straight down. And now I'm hitting this one. I got a little wiggly, but I am hitting this one perfectly. And they line up, and it's 1/3, 1/3, okay, is equal to what? If we were to stop right here, what fraction would we say is it equivalent to? 1/3 is equivalent not to just 1/6. Many of you guys might want to say 1/6, but how many sixes are here? There are two of them. There's two of them. So 1/3 is equivalent to 2/6. Okay? Now I want you to name a fraction that are equivalent to 1/2. So here we have our 1/2. And I'm actually going to go ahead and go to my next slide because we did this in our previous lesson. If you think about if we drew a line straight down, you can name all these different fractions that are equal to 1/2. And you'll be able to see it in my next slide. So there is some fractions that are equal, perfectly equal to 1/2. Okay? So here is one that I showed you guys from our last lesson. So we had 1/2, and the first one I stopped at was our fourths. How many fourths were equal to 1/2? You can look at my pizza slices, and there were 2/4 equal to the same 1/2. If we keep going down, we would have seen that 3/6 was equal to 1/2. If you keep going down, 4/8 were equal to 1/2. And there is actually one more, and that is 5/10 is equal to 1/2. Okay, 1, 2, 3, 4, 5. So we also could even add in there 5/10. So we have 1/2, 2/4, 3/6, 4/8, 5/10. Now, I would like for all of you in your notebooks, I would like for you to explain. What do you notice? I want you to explain. What do you notice about all of the denominators of these numbers that are equivalent to 1/2? So if I were to write them all down, so we have 1/2, we have then 2/4, we then have 3/6, we then have 4/8, and lastly we have 5/10. Okay, what I would like for all of you to look at, every single one of you, okay, I would like for you guys to think about what do you notice about the denominator in each of these fractions. I'm highlighting it. The denominator in each of these fractions. What do you notice? Explain what is happening to each of our denominators. What are we skip counting by almost? Think about it. All right, after you've written down your explanation, I'm now going to say we can notice, I'm noticing something, that each of the denominators are actually, we are skip counting by 2s. If you look at it, it goes 2, 4, 6, 8, 10. And you might even notice that the numerator, or the top number, is increasing by 1. There's 1, 2, 3, 4, 5. It's really cool. These are all equivalent fractions. We can also say that these numbers are even. The bottom numbers are even. Okay, now we are looking at this next question, still looking at our fraction bars, and we are looking to see, is 8/12 equivalent to 2/3 and 4/6? So I'm going to box what we're talking about. So here, I would like for you guys, you can draw pictures or you can try to just watch my screen. And we have 2/3. Now, if you do draw a picture, make sure that you are drawing the same size squares or rectangles or circles, because if you're drawing all different sizes, then it doesn't show you an accurate picture. Okay, so here's 2/3. Then we have 4, 6. So I have 1, 2, 3, 4. Okay. So are these two equal? Is 2/3 and 4/6 equal? Can we see that? They look pretty equal to me, and they actually are equal. So if you were not sure if 2/3 and 4/6 are equal, they are in fact equal. Now we just need to figure out, is 8/12 equal to them as well? So I have 1, 2, 3, 4, 5, 6, 7, 8. All right, and what do we see? Do we see, is 8/12 equivalent to 2/3 and 4/6? The answer is yes. If you said that 8/12 is equal to 2/3 and 4/6, give yourself a star or a smiley face because you were correct. Now, we are going to be looking at different models just briefly today, and I am going to tell you that this is going to be part of your assignment today. If you look online, there is going to be a post of a quick worksheet you can work through, just like we would in class. And this is just looking at different models, different types of ways we can see our fractions to see that they also might equal the same. They might be equivalent. So we're going to look at different models, and I'm going to tell you that these 3 wholes are the same. We need to name the shaded fraction, and then we're going to see how they are the same. So this first fraction is what is shaded. We're naming what is shaded, and this would be 1, 2, 3. 1 out of 3 is 1/3. Now, I know that most of you should be making notes or taking notes. If you can, draw this same picture. Okay. Now, our next visual, if I were to rotate this rectangle to the left, you would see that this same, let me make sure I highlight it. Okay. This same part of the blue would line up with this part of the blue. We just would need to rotate it to the left. Okay. And we know that this one was 1/3, but how many equal pieces do we have here? We have 1, 2, 3, 4, 5, 6. Okay, and 2 of them are colored in, so this is 2/6. Now our last one is that if these 3 smaller cubes or pieces were all lined up in a row or a column, they would also line up really well with these fractions over here, these shapes. Okay, So we know that this is also equivalent. However, there are more pieces. How many pieces are there in all? That will go on our denominator. And then however many are shaded goes in our numerator or on the top. So how many are in the, how many are all together cut up? How many are together in all? We know it's 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 pieces altogether, and there are 1, 2, 3 shaded in. Notice with these ones, there is a pattern you might notice, and we know that we're skip counting by threes. 3, 6, 9. If you were to make a prediction, what would be another shape that would be equivalent to this one if we were skip counting by threes? You can go ahead and draw a picture of what you would predict that would also be equivalent to 1/3, 2/6, and 3/9 based on skip counting by threes. Okay, so on your worksheet, it's going to not be the problem set. It's actually going to be another worksheet, but it's going to be very similar. I just want to walk you through it really quick. You are going to have to write the shaded fraction of each figure on the blank. You are then going to draw a line to match the equivalent fractions. Now you can see these two are not equivalent, and what you will see is there's going to be entire columns of all different figures. That is what you're going to draw arrows to or lines to. Okay? As we end our video really quick, I do want to show you a way that you guys can go online and find a new resource. Now this is the resource I am going to show you if your parents are on Class Dojo. So I'm going to show you, they go on Class Dojo, they go to the class story, and they are going to look at the post I had earlier today, and it gives you all these different resources of things you can look at online. One of the things I would like for you guys to go ahead and look at is the second link. It's called mathplayground.com, and you're going to click on Scale Fractions. Okay, and when you get there, you can go on your full screen mode. Oh, I'm not going to do that. Never mind. And you're going to want to drag the fraction bars to the scale. I want you to pay attention in this bottom part. It says it's either if it's equal or if it's bigger than or greater, like greater than, I'm sorry, or less than. So we're going to start with 1/2. 1/2 is greater than nothing else right here, right? But we have learned that 1/2 is equal to 2/4. 1/2 is in fact equal to 2/4. So you guys can go ahead and explore all the different ones that they might be equal to. So for example, I might want to know what is 1/2 equal to how many twelfths? Okay, so I have 1/12, 2/12, 3/12, 4/12, 5/12, 6/12. Okay, so I stop there and look, 1/2 is in fact equal to 6/12 as well. So you guys can go ahead and click on that link after you look at it on Class Dojo, and then go and explore more about what is equal on this fraction scale. I hope all of you guys have a really awesome weekend and just have a really fun time with your families. Continue to wash your hands and just stay safe. I miss you all.